While we are looking at the structure of scripts, I want to introduce the simplest and most common form of structuring, namely the block statement. To do so, let's extend the original sphere creator for loop example a little, so that it not only creates the spheres, but say creates an orbital ring for each of them, something like this. You make a block simply by grouping a sequence of statements or expressions in parentheses, like this. Now the body of the for loop is a block, and all the lines in the block will be executed in order each time around the loop. You can see I've simply added a torus constructor to the body, so now each time around two objects are created. Let's run it, and yep, we get what we want. Anywhere you can put an expression or statement, you can put a block instead. For example, I can also use blocks as then and else branches in an if statement, or as the body of an event handler in a rollout. Since I can have as many statements as I like inside a block, these bodies and branches can be as complex as I need. As well as putting blocks in these places, I can also put other sequence control statements. So ifs inside ifs, or fors inside ifs, or even fors inside fors, as in this example. When I run it, you see we get a stack of touching spheres. I've made the original sphere loop the body of another loop, so the inner loop itself gets repeated a number of times under the control of the outer loop. In this case, the outer loop is a range loop that makes its loop variable z have the values 0, then 200, then 400, and 600, because I added this optional by clause, which sets the increment on the loop variable each time around. Then, I use the z-loop variable as the z-coordinate for the row of spheres created in the inner loop. So the first row has a z of 0, the next has a row of 200, and so on. Blocks that are part of nested structures in your scripts are consequently associated with their nested namespaces, and in fact form the boundaries of these namespaces. So, in this example, the loop variable I is visible and usable throughout the block. We can create other local variables as needed inside such blocks with the so-called local variable declaration. Let's say I wanted to link each torus and sphere pair, and then rotate the hierarchy upright. I need to be able to work on the objects just created to do this, so the simplest thing to do is to capture them in local variables and work on them through the variables like this. The local word introduces a local variable declaration, which is a comma-separated list of one or more new local variables with an initial value assignment for each. Each time around the loop, the local variables s and t will contain the sphere and torus just created. The .parent property on a scene object contains an object's parent object if it's linked into an object hierarchy, and simply by assigning to it, like this, you can set up link relationships. In this case, I've assigned the torus as the parent of the sphere. Then I rotate the parent torus 90 degrees around the y-axis, which of course takes the sphere with it. Remember that because s and t are local variables inside the for loop's namespace, they're visible to code only inside the loop's body, and won't clash with variables with the same name outside the for loop. And they only live for the duration of the for loop. I also like to make liberal use of locals to simplify and clarify scripts. In this rewrite of the loop, I pulled all the numbers and expressions out of the constructors and made variables to hold them. This lets me see all the main expressions up front, which I can break into as many sub-expressions as I need to help build up the final parameters, and lets me factor common pieces of code so I only need to write and maintain them in one place, like the x position expression or the radius delta here. The x position was in 2 places in the original script, and the radius delta was in 3. But in this version, they're factored into single variable declarations, which makes it easier for me to change if I need to later on. This is really a coding style issue. The 2 versions generate exactly the same results. Even though the rewrite is longer, I found over time that breaking things out like this helps getting them right in the first place and helps updating the code when you come back to it later. Another recommendation is to use meaningful variable names. You can make them pretty much anything you like, but if they're too cryptic, nobody, including you, will understand the script after a while. Although it's common to declare locals at the start of a block, as I've done here, you can introduce them anywhere in the block, and they're visible from that point on. Now it turns out that you don't actually need to use explicit local variable declarations to create new variables. Just assigning to a variable the first time will automatically create it. If you do this inside a nested block, the new variable will be created as a local at that level. So I could have written this. You see, no local declarations, just plain assignments, and the variables are created automatically. However, this automatic creation only happens if the variable is not already created and not already visible at that point in the code. So you can't be sure the variable is always going to be a new local. It could be already declared in an enclosing block or be a global variable. And if you really were expecting it to be the current block's own local variable, you'd likely mess up things in the outer blocks. Even though it does involve a bit more typing, I strongly recommend using explicit local declaration statements to introduce new locals at all times. I generally only ever use undeclared variables if I'm tinkering away with some code experiments in the listener. You can also declare variables to be global using the global variable declaration syntax like this. This has a similar syntax to the local declaration with the word global instead. Recall that global variables are visible throughout all scripts and so are often used to hold values that need to be shared by many scripts. You would use this if you wanted to create a new global variable at some point in your script, or to make sure that uses of a particular variable in a block of code are guaranteed to be references to the global variable of that name. This is sometimes needed if you can't be sure the global will already be in existence when the code is first read by MaxScript. You might have several scripts that are run at different times, all sharing a certain global. By making all references to this variable use an explicit global declaration, it doesn't matter which order the scripts are loaded.